Hi, what's inside an $18,000 Agilent N9344C 20 GHz spectrum analyzer? Well, the people at the RF design division at Agilent thought we'd like to know, so they sent one for the teardown. You know what we say here on the EEVblog, don't turn it on, take it apart. So unlike Tektronix, who was scared that I would break their precious spectrum analyzer, Agilent, the RF design division, said, yeah, no worries, take this, tear it down, have your way with it. Beauty. Thank you very much, the RF design division at Agilent, for supplying this. Oh, I can see myself. Reflective screen on this thing. We have the N9344C. Geez, I wish they'd get better model numbers. I mean, who pulls that one? Who pulls that model number out of their ass? Really, fair dinkum. Anyway, 1 megahertz to 20 gigahertz. Awesome. So we're going to have some excellent RF magic in here. Fantastic handheld spectrum analyzer, real high-end bit of kit. As I said, about 18,000 Australian dollars, designed for field use. It's got over-molded rubber around the outside, just in case you drop it. It's really hefty. I don't know, it's at like 3 kilos or something like that. And it's got a nice little springy stand on the back. Oh, look at that. Oh, I could play with that all day long. Nicely screwed in there. It looks like it would survive. I don't want to rip that off, but yeah, seems pretty rugged to me. It comes from the Chengdu Instrument Division at Agilent Technologies, from the marketing department. Hello, Song Tian. Good on you. So this is obviously one of their demo units or something, lithium-ion battery in there, and we'll take a look inside to see what's in there. But let's have a quick peek at the top here, shall we? What have we got here? We've got our RF input here, 50 ohms of course, our 50 ohm RF output, both end connectors, all standard, and that's for the tracking generator, of course. And it's got little protective caps on there. Beauty. External trigger reference, GPS antenna, very nice. You could get some nice applications with that. External power for the charging, built-in LAN, USB, headphones as well for getting the modulation output. Fantastic. And a user interface on the front. We're not going to turn it on because we're going to take it apart. Now it looks like there's a few Torx screws on this thing, but this one here is a, looked like a Phillips. Smells like a Phillips, but I ain't getting anything on that. If I get my flathead in there, hang on. No, smaller flathead. There we go. We've got some sort of port here. I wonder what that is. That's the battery. There we go. We'll take the battery out. Tyco Electronics. There you go. 4.6 amp hour, 10.8 volt. Must be recycled. Oh, look at that. Battery gauge on it. Beautiful. Fully charged. I can smell it. Whee! Alright. We got $20,000 instrument smell. And it looks like, oh yeah, look at that. Even first cab off the rank here. I probably won't be able to see in there, but they got little springs attached to the top of the case all the way through there, just to put some extra downward force on the battery pack. Nice attention to detail there. I'd probably have to turn the contrast up for you to, there you go, you can see them. Nice in there so it doesn't vibrate and all that sort of jazz. So very nice attention to detail. I like that. That's a good start. So let's whip this puppy open, and we have a Torx. It must be a T10. I had a T15 in there. There we go. T10's the ticket. And of course, I'll post some links to spectrum analyzer teardowns or RF teardowns I've done before, and my Torx isn't going to fit in there. Oh, bugger. Hang on. Oh, I can just get that one. There we go. Alright. Yes, folks, it is Teardown Tuesday. There we go, 3 PM. Hopefully I can finish this before I have to head home. Apologies if I can't. But anyway, we expect to see inside here, not much on the processing side of stuff. We don't care about all that sort of stuff. You know, it'll just be a some sort of processor. I'm not sure whether it runs like embedded Windows CE or something like that. most likely run some sort of embedded OS, but yeah, not too fussed. What we want to see is inside the RF cans, of course. They'll be all fully machined cans with RF shielding gaskets on them, and we will see lots of PCB component technology as well, lots of inductors and stuff embedded into the PCB, and capacitors and various components and bandpass filters and things like that, all sort of, there we go, all embedded into the PCB, which won't be a regular material. It'll be special controlled impedance, and it'll be very, very nice. These spectrum analyzers, they cost a lot of money for a reason, and to get 20 gig bandwidth is quite an achievement. There we go, we're straight off. There we go. Ta-da! Oh, look at that! Look at that! Beautiful. Oh, there it is. Precision machining. Look at all the the big, fully machined aluminium blocks there for all the RS stuff. We've got some rigid coax down here. We'll take a look at. Ah, 2 FPGA, 2 display, COM. Oh. And on the back of the case here, we have little slots for the handle on the side. Looks robust enough. I guess I would have maybe liked to have seen that be screwed into the aluminium blocks or something like that, just for rigidity. But obviously quite a good quality impact resistant polymer plastic they'd be using on this thing, no doubt. But interestingly, have a look at the shielding tape they've put on there. That'll be some sort of ferrite impregnated shielding tape or something like that. I don't think that is regular tape there, folks. So just a little bit more shielding on the back side of the case, I think. But isn't this a thing of beauty? Look at that. Fully machined aluminium blocks. You can see the PCB wedged down in there. There it is. You can see the PCB down in there, and so they've got a top shielding block, bottom shielding block. So if we take off these top shields, we'll be able to see the top half of the board. Then we'd have to get the board out, presumably to see any components on the back side of the board. Then we've got another board down in there, and then we've got at least a third board right down the bottom there with its own cover shielding plate. And there's that rigid coax I was telling you about, joining these two blocks here. So they've got that rigid coax. That'll be like 20 gig bandwidth or whatever they need. There looks like they've got SMA connectors on there going from board to board. Look at all the vias on there. Look at all that via stitching there to get the impedance, get the inductance right down. So fantastic. That one's got and they've got center mount board connectors in there, mounted right on the center, so the pin that comes out we'll probably see that when we take the board out. The pin's on the top side, and it goes direct. The center pin, is on the bottom side of the board here, and that's connected directly to the correct width trace on the bottom side of the board. So there's no pin which comes out and then goes right angle down like that, because, well, at 20 gig, that sort of stuff matters. So look down in here. Looks like we have some status LEDs down there. They're not marked though, but obviously there's some sort of internal service status. We've got some sort of that could be like a JTAG programming or debug header or something like that. We've obviously got another micro board coax connector on there, and probably used for another option or something like that. But then we've got some regular coaxes going around to here, which then we follow them around. Let's have a look at where the inputs are. So here's our RF output. So here's our RF signal output. Then we've got rigid coax there. So this is our generator board. So that looks like probably, I'd say that module there is our tracking gen. Perhaps it makes sense to keep it completely separate, and that's why then they've got the join going out like that. So then the output frequency of this can go into the tracking gen. So the sweep frequency in here of the spectrum analyzer, this would be the spectrum analyzer module, then that can drive the tracking gen over here. Completely separate, of course. You don't want any crosstalk between those at all. Absolutely essential. And Then here's our main RF input here, very short rigid coax. Of course, if you don't know what rigid coax are, they're various technologies go into them, but it basically feels like it's like a complete copper rigid outer pipe. I mean, there's no flex in that at all. It's not a regular cable. It's basically a solid coax cable. That's basically what you've got there. And then we've got our, that's our, what's that? That's our external trigger input, and then we've got a GPS. There's our GPS antenna. There it is, just spotted it. There it is there. It's just got a patch antenna there. Nothing particularly special at all. GPS module that goes off, and then the external antenna over here. So it looks like they've got an internal patch antenna and then an external, optional external antenna as well. So it will work with the internal antenna. You can see it's patch antenna due to that center point, and then the antenna pad on the top there. So typical patch antenna. Their performance isn't that great, but certainly adequate for getting reasonable, well, you know, something out of the thing anyway. So there's our GPS antenna goes around, external trigger. So that's the external trigger coming around here. The external trigger's going down to the main board, so the trigger's not going into the processor. Of course, it's not going into the Spectrum Analyser module up there. What else have we got? Then we've got our, what else have we got? Interconnect wise, we've got our main processor board here going up to our, that looks like the bottom. Well, there's one board, there's one complete board going across both of those modules. So I'm presuming the Spectrum Analyser module here in the tracking gen, looks like that second board there goes all the way between the two modules. So interesting. But yeah, obviously you've got to connect the processor over to there, and we've just got some flat flex here going down to the keypad, display, whatever, some dip switches, and not much else. But interestingly, there is of course going to be an FPGA in here. There's a display. Looks like we can take off this panel here. And there we go, we've got our JTAG for our processor and our FPGA as well. And interestingly, I love this. Check it out, they've got a big inductor there. Obviously it was too high for the main, to get under the main cover. So they went, oh bugger it, let's just put a little cutout in there, and then we'll put the plate over that. It'll all be nicely shielded anyway. Beautiful. But check out that. I mean, even the plate, they've had to machine out a cutout in there so it doesn't short out the pins that actually aren't flush with that. Those pins actually stick out a little bit there. Just, you know, attention to detail. That's why these things aren't mass manufactured in their tens or hundreds of thousands, you know, so they can afford to just machine a single plate just to do that. Brilliant. Now, of course, to get all this apart, I'm actually going to have to take off these rigid coaxes here. I'm going to have to unscrew those, get a spanner in, and unscrew those suckers out. And by doing that, I'm probably voiding the calibration on this thing, of course, because when you're talking about a 20 gigahertz bandwidth connector like this, even the torque on the thing matters. Really, or it very likely could. So yeah, the odds are that, you know, I'm not going to damage anything by taking it off, but the thing actually might need a recal after this, certainly. And off we come. And they should just pull out like that. So, there you go. There's a 20 gig rigid coax. And there's a close-up money shot for you connector aficionados. And of course each rigid coax has its own, custom assembly and is probably, individually tested and characterized as well. I wonder how much just that individual component costs them. One of the things I love about this construction with all the machined solid aluminium block is like this connector is not going to break off. You know, you get some heavy ham-fisted production or field operator or something like that. And look, it's just, screwed directly into the full chassis of this thing. Unbelievable. And I love it when PCB layout people put these visual layer guides right on the side of the board. They just bring the copper right out to the routed edge. One of the dangers with that, of course, is that you can actually short these out. Now, a bit of context here, if you're not sure what you're actually looking at, you've got the top aluminium block up here, Sorry, I got this propped on an angle. It's going to bounce around a bit. Bottom aluminium block in here, and the PCB, multi-layer PCB wedged in there. This is actually the tracking gen module, or what I believe is a tracking gen module, and you can count the copper layers in there. Have a look. Oh, my pointer's not fine enough, but 1, 2, 3, 4, 5, 6, 7, 8 layer board in there. Obviously, you know, alternate ground and power layers and stuff like that. But that allows you to see the actual copper in there, and that there, if you're wondering what that is obviously an RF gasket on there sealing the top of that board. That's what it looks like anyway. Now, of course, if the layout person is smart, that copper there won't actually be connected to anything at all, because of course you could easily get shorts on the outside of this board when it's routed, snapped, or whatever, or you connect into something, you know, touching metal next to it or something like that. You can short it out. So what they'll do is just, well, it's not on the side, I have to show you a top view, but they would just have an isolated island pad in there which isn't connected to anything, just floating copper, which then goes right to the edge, which then gets routed off when this board gets machined. Now, I think I have all the screws out for this top one, this top connector module up here. Ta-da! There is our spectrum analyzer module. Well, presumably, well, the front end for it anyway. It's probably the front end. There probably a lot of the spectrum analyzer stuff is on that secondary board down the bottom, and we've got our tracking gen there. But oh, look at the number of screws we've got to take out, and look at that board-to-board interconnect. Ta-da! Of course, that's not taking, you know, RF frequencies and stuff like that. It's probably only taking the lowest frequency out to the analog to digital converter, plus all the control signals and stuff like that, of course. So that doesn't need to be particularly high frequency. And this pink cover here that just comes off is likely just a thermal pad, like a sill type pad, just to get good thermal coupling between the block, which presumably gets quite warm, and the rest of the aluminium here, which can also act as a bigger heatsink as well. And there's that board-to-board interconnect for those curious in such things. There you go. You can see the center power tabs down in there. They can carry reasonably high current, likely. Anyway, I don't think they're just, they could just be ground shielding tabs or something like that. These are usually quite, you know, high frequency connectors, but obviously it's not being used for here for the, you know, the high end RF signals. That's all contained within the block. So as I said, just control and probably the final IF output as well, or that might come via one of the coaxes over there perhaps. And I think I've got the screws out here. These have some screws on the bottom, so I'm not going to get this top plate off without taking out this whole board. Yep. There we go. There's probably some interconnects. Yeah, there's some interconnects down in here, and that sort of stuff. I'll be able to show you that in a second, but there you go. You can disconnect those. Not terribly exciting stuff down in here. You know, like would you even bother taking that off? It's just the LCD controller. So yes, there's absolutely no shortage of shielding on this thing. There's the LCD display. It looks like it's an NEC model NL64480 or something like that. I don't know. I don't think I'll even bother taking off that. And then you've got your keypad down in here. That's not what we're here for today. There will be some microcontroller goodness under here, so let's check it out. Check out that big Pulse brand inductor there, or common mode choke, absolutely massive, sticking out the bottom side of the board there. There we go. Ha, look at that. We're in like Flynn. And interestingly, check out the bottom here. Thermal pads. They've actually molded the aluminium plate so that it actually used as a thermal, heatsink, designed in to connect onto all of the major heat generating packages in there. Brilliant bit of systems engineering. I love that. A lot of thought and attention to detail has gone into that thing, and you can see the thermal sill pad on top of each one of those chips lines up. So, you know, there's got to be a a lot of communication going on between the PCB layout guys and all the mechanical housing guys and all that sort of stuff. So excellent work, well done, huge thumbs up on that. Well, now the really interesting part about this, which I didn't expect to see, is yet more shielding blocks inside here. My only guess would be that would be the analog to digital converter, something like that. This one's got a relay poking out of it there by the looks of it. But yeah, so it's obviously taking the input signals from outside the main shield here, rounding them under the outside shield into these shielded blocks. You can see all the grounding vias all the way around the outside of those to add some extra shielding, lower the ground inductance, yada yada yada. But yeah, obviously those RF, intermediate frequency lower, it's not the full 20 gigahertz bandwidth. They actually mix that down to a lower frequency before it goes into a relatively slow analog to digital converter in the, tens of megahertz range. We'll have a quick look at a couple of major parts on here. We've got ourselves an Epson S1D13748 LCD controller. Nothing special. Is a bit of a beast. It's got 1 meg SRAM built in, and then we've got our LCD driver up there, and there's our LCD interface cable. And there's our DSP, Analog Devices 21363. Yes, it's one of those Shark processors we've seen a lot recently in Rygold gear and other stuff. Bit of a beast, 3 meg internal SRAM, and that's coupled directly into an Actel FPGA there, which we'll have to take a look at by peeling the sticker off. Then up here we've got ourselves a Crystal Ethernet controller. Nothing else major on this side here. We've got some memory down there, and that looks like our main processor. I think I can see ARM down in there, because basically we have 3 technologies coupled in here. We've got our DSP, which would be doing all the heavy lifting in terms of the stuff from the analog and stuff from the ADCs down in here, and then we've got an FPGA. It's just, I don't know, doing some glue logic, some really fast parallel processing or something like that. And then, well, we don't know the complexity of that one yet. And then we've got our main processor over here, which would be controlling the user interface and everything else. And you probably can't read that, but that's an Actel Igloo / micro semi Igloo AGL 400 V5. So that's actually quite a sizable FPGA, 400K gates, about a $50 FPGA. And then we've got some nice looking power supply stuff up there in the corner. Beautiful, nicely laid out. High current traces, you can see that. We've got more power supply stuff happening over here, and lots of little local regulation and core voltages everywhere. But yeah, that pretty much does the business. It looks like we have a real-time clock down here. You can tell from the 32 kilohertz watch crystal down in there by the looks of it, and a little tiny package, external RDC, and that about does it for this side of the board. So I suspect there's more on the other side, so let's flip it over. Nothing terribly exciting on here. Some more power supply stuff. There's that huge pulse common mode. It looks like it is a common mode choke because it's near the DC jack right up there that you saw poking out of the shield before. Just some more memory down the bottom there, and we've got our real-time clock battery. We've got the bottoms of our shields, which we'll take off in a minute. Micro SD card. There's no card in it, but it does certainly have an internal micro SD card slot. No idea what that's for. And more power supply stuff. Well, hello, we have a couple of bodge wires under here. Look at that. There we go, some enamel wire going from that trace over there, over to there, another little bodge in there. Yeah, there you go. Well, the complexity of this thing, and I guess they couldn't be bothered respinning the board. They just found, oh yeah, let's just hack that in there a bit. No drama at all. Let's take a look at what that puppy's doing there, because I'm presuming that the tracers obviously come under the shield in here from these 2 connectors here. I believe from memory this one wasn't actually connected to anything, but this one here certainly was. And surprise, surprise, AD9235, 12-bit ADC, 40 meg samples per second. This mod down in here is interesting. Take a look at this. That looks like a 0 ohm jumper there, and it looks like, and they've got that enamel coated wire going over to there. So they're like joining those grounds together. Interesting. Did they have some sort of grounding problem or some sort of performance issue or something like that they had to fix? I don't know. Quite unusual. And the back of that shielding block there, no surprises, just all the bypass and other miscellaneous passive stuff. Well, underneath the other block, there's not much at all, but it looks like, for example, like here's the RF connector down here, and there's another one here, so like that's going to flow into here somewhere. So it looks like, you know, it looks like we've got some RF you know, probably like an RF transistor or something like that. I'm not sure. I forget what was actually connected to this point down in here. And of course, one thing we've been missing so far is the 10 megahertz reference oscillator, and there it is. It's a Raycon. We'll get in there and have a look at the particular model number, but looks like we've got a couple of devices up here. We'll check those out. We've got, looks like another 10 megahertz oscillator down in there. Oh, and I think I see a bodge cap. And no surprises at all to find a clock generator such as this ADF4001, 200 megahertz programmable frequency synthesizer. We've got an AD829 precision op amp there. And down here with a little bodge cap tucked in there. Hello, look at you. That looks like another oscillator. Looks like a 40 meg oscillator. There it is, 4 meg 000. And there's the Raycon VTX0210A-5 10 megahertz, presumably temperature compensated oscillator with what looks like a trimmer cap on the top there. Unfortunately, that's not going to work anymore because it is now upside down. And of course, with these precision reference oscillators, you can't have them upside down because all the crystals just settle to the bottom. It doesn't work anymore. And for those playing along at home, this is PCB Rev 3. So what we've got here is our main reference oscillator and frequency synthesizer, which then gets multiplied up, of course, in frequency in the tracking generator and other parts of the system. Secondary oscillator down here, not sure what they're doing with the secondary oscillator, but then our ADC under this block here, and that is what gets, you know, all the low phase noise of this spectrum analyzer. Really good oscillator, really good mixes higher up and stuff like that in the RF block. So I think it's time to take the RF block apart, but you'll see the machined aluminium cover that they went to all that trouble. They sealed off all the individual sections, all under there, done it properly, belt and braces. They've got a couple of test pads over here on the side of the board, but as far as like production test pads and things go, I really, you know, don't see anything else on here in terms of that. So all the, you know, they just assemble this board and, you know, do the basic programming of the FPGAs and all the programmable devices, and then they just do thorough, you know, software-defined tests in the things and calibration, you know, all that sort of stuff. So they're not actually doing a huge amount of tests at the bare board level, I suspect. And it goes without saying, I think that the soldering on this board is first class. Just a tip for the young players, when you're reassembling something like this, make sure you have the cables actually sitting outside before you put the shield on. Oh! Alright, that was a fair few screws, but let's, hey, lift this off. Oh, there's our gasket. Oh, ta-da! Look at that. There's our gasket. Beautiful. What's that made out of? Lovely. Look, there you go. That's the material. It does feel metallic in some way, but yeah, I'm not sure. If you know the exact material actually used for this RF gasket, please leave it in the comments. So this is our tracking gen board, and I think it's going to just lift out because really it is just shielded. Like I don't think there's, no, there could be a board-to-board interconnect over here or something like that just for some control stuff, but of course all the RF goes through the connect. Yep, there we go, board-to-board interconnect, there it is, connects down to the bottom. I thought, you know, you can tell by the traces in there, kind of a dead giveaway. And there's another gasket on the bottom there, of course. Beautiful. And all fully machined, each individual section, of course. I won't go into details. I've seen this in RF spectrum analyzers before. This is a Rev 6 board of the tracking gen N9344C. And that is, ta-da! Oh, there it is. There's our tracking gen. And yes, ta-da! We have our first look at some PCB filters and stuff like that all in there. There we go. Typical RF stuff. And you know how I mentioned before about the center pin of this thing coming through the top of the board? Well, look, it's actually completely shielded on the other side. There you go. So, yeah, the top side is, of course, you know, there's no center pin popping out there. And on that side, no, nothing. It's all contained in there. Then it's going through to an inner layer, through, probably popping up there somewhere and going wiggle, wiggle, wiggle into there and across. And we could be here all day trying to look at this thing. But this is rather interesting. Actually, look, they've put some solder on top of that trace there. I wonder why. And one interesting aspect to note is, look, you can't actually see the holes in the vias there. Little micro vias, obviously, used in this thing and plugged of some sort. But you can see the signal coming in from the connector here to be going through a center layer like there, to be going through here like this, hence the these are vias around here to reduce the shield around here and reduce the inductance of the ground plane and all that sort of jazz. And it pops up here to the top layer. This is all controlled impedance PCB, by the way. It's not just regular stock standard PCB you'd get from any manufacturer. Very carefully characterized, of course, for controlled impedance applications. And AC coupled there, going into that device there. I have no idea what some sort of, well, I don't even know what this connector is used for, actually. So I'm not going to try and go through and decode every single part of this. Sorry, folks, it's just not worth my time, really. So I guess you could look up that. I don't know. Is it like a RF amp or something like that? So I'm not actually sure what these devices in here are. Haven't looked them up yet. And splitting off. And then we'll go through and we can start then seeing some RF filters and stuff in here. And then coupled here, there's a RF transistor for what, an RF amplifier for sure. They've and then it goes up here, boom, into another device, you know, all over the shop. And then we start getting into the RF wiggles in there. They're just putting in an inductor in there. All right, so let's see if we can vaguely follow the signal here. This is our tracking generator output. This is our 50 ohm output here. It's AC coupled. There's obviously some drivers here. So we're going actually backwards through this process. So if we've got a couple of other devices. I have no idea what they're doing. I have no idea of the topology. We've got obviously some filter, maybe perhaps a mixer down in here, perhaps. Then we've got some filtering going on in there based on the PCB. Not sure what that one's doing. That's obviously an RF transistor down in there. Then it's going through. You can see then it just sneaks through a gap in the wall of the shield down in here. Then we've got another 424 LT3 device that we had down here. We had a couple of those 424 LT3s. And then just off that, we've got a 74HC04 inverter. Look at that. Brilliant. Not sure what that puppy's doing in there. But anyway, we have some, looks like we have some inductors there on the board. And then, yeah, I'm going to probably get complaints about poking around on this board with a screwdriver. Shut up. Really, it's not worth complaining about. I know what I'm doing. And then it sneaks through. We've got another probably amp there, and then or buffer, and then we've got our controlling impedance traces going through here. We've got another device there, whatever that is, and then we have some what's probably a bandpass filter. I haven't looked at the topology, haven't thought about it, but as I've mentioned in previous videos, those traces out, you know, why do they have like a stub going out there like that? Well, that's actually an inductor in there, and it's got resistance as well, and that actually acts as a capacitor there. So you can actually have you know, low pass and band pass filtering and things actually integrated into the PCB, and that's exactly what they're doing there. And then we're going over to whatever this little hybrid is here, little 8-pin hybrid. It's a SIM24MH, whatever that is. Then we're going into a ceramic package, a couple of ceramic packages over here, H564, local oscillator, LO32, okay, so they're presumably local oscillators down in there. Then we have our main control device. We'll have to rip that off, see what it is, not sure. We have our board-to-board interconnect, of course, there, and check it out, we have a board-to-board RF connector. Doesn't that look funky? Geez, ET could phone home with that thing. And there we go, there's the made-in RF connector through there. So that's probably getting out the, you know, one of the local oscillator signals or something like that over to our tracking gen. And that's where we follow the signal around like that from our output way back here, around there, through the, what looks like bandpass filter there, through some local oscillators and stuff, and back over to here. But then we've still got these isolated sections here, some more filtering going on there. You know, it could be like a low pass filter perhaps. And but these blocks, I mean, there's a connection between this block in here, like this down to here, but it seems like that block is almost you know, isolated. It could be something, there's probably something sneaking under through there, perhaps going from there, jumping over to there, and yeah, maybe, no, there's nothing going there. So, you know, these things are sneaking all over the place. You've got to be careful, but it almost looks like all of that is sort of its own isolated block there from this main path, which sneaks around here like this, all the way back there. Anyway, I don't have a block diagram of the tracking gen. I'm not going to try and reverse engineer it to get it out. If we take the other shield off here, we don't actually get anything all that interesting. Look at that, it's pretty barren. So we should actually, like we've even got some, you know, basic SO8 packages here from Linear Technology I can see, and we'll go in and take a look. But here's the main RF input over here. Of course, I have to take out that rigid coax before I lift this board out, but yeah, nothing exciting there at all. As you can tell by the traces over there, that's another board-to-board interconnect, same as what we had up here, of course. And there could be another RF board-to-board. I'm not entirely sure. We'll find out. But yeah, let's lift that board up. There should be some more interesting stuff underneath. But first of all, once again, got our RF gasket there, and ooh, a couple of nice little traces in there we'll check out. But let's have a look at some of the chips on the top first. USA, USA, USA. Well, this right here is a very interesting part of the circuit. I really like this. Check out what they've got happening over here, and trace snaking its way around there into this 4-leaded device. I don't, you know, it's like it's, you know, a typical RF you know, amplifier configuration kind of thing, but you know, it's just, I didn't expect it to see in a square plastic package like that, sort of rotated 45 degrees. Bizarre, but anyway, yep, they've got some basic RF stuff happening there. I don't know what that is. Your guess is as good as mine. So if anyone's got any info, post it. And we've got ourselves a couple of Burr Brown. I love Burr Brown. Then our TI, of course, OPA 4251 micro power op amps. Nothing at all special there. If we move up here, I wouldn't even like to hazard a guess on that one. And then these devices, they're everywhere. Check them out. There we go. There's 2 of them there. There's another one over here. And then over here, same device. 4 of them. And on the flip side of that, got ourselves the RF gasket again. Ta-da! We have a couple of, yeah, board-to-board interconnect and a couple of board-to-board RF connectors. And, oh, look at the back. Very sexy. Gold as far as the eye can see. Unfortunately, not something that we're going to be able to take apart, because these things are usually soldered completely shut. And yep, they are. I can't just pop the lid off that. It's not just like an RF can. You can just pop the lid off. Oh, bummer. And We've got some interesting stuff happening down in here. Once again, no idea what that device is. RS section AT4 attenuator. Perhaps some sort of attenuator going on there. Low could mean a low pass filter is going on and there. If you want to know where that is relative to the other side, that one actually is the same block as that contains that funny little wiggle in there with that little amp or something down in there. So that's the back side of that block. What we've got under that little firmware tag there is an XC2C128 Xilinx. That's actually not an FPGA, that's a Cool Runner CPLD, complex PLD. And we've got a couple of linear technology parts all around that. Not sure what they're doing, not going to look them up. Just little precision op amps or something like that. Not terribly exciting. Unfortunately, all the magic happens under these cans and we can't get to them. What's under that? Is that wouldn't be is that an access port? Because that looks like copper tape. A copper... No, what is it? Whoa, we got ourselves a little hole under there. Little access hole. Wonder what's going on there. But that, yeah, is sealed with copper tape there. So, shield that, you know, we're talking about 20 gig here. Put a bit of spit back on that. She'll be right, no worries. But, yeah, little access hole under each one of those. Got those lovely board-to-board RF interconnects again. Another LT part up there, but obviously not a critical part of the anything outside of these shielded cans, of course. Nothing to do with the RF part of it. They're just basically control circuitry and stuff like that. So nothing of terrible interest. Likewise, this stuff around here, yeah, it's inside the block over here. Here's our block. There it is. The block has its own, you know, thing there, but obviously not quite as critical as what's deemed to be inside one of these shielded cans, but you know, still good enough to have all its own machined block and everything else. That reminds me, I forgot to look at the device on the tracking gen board. Yeah, exactly the same Xilinx Cool Runner CPLD for a basic control and interface. And somewhat curiously, this main block down here, actually for the tracking gen, has its own back-in module on it like that. So there you go. Maybe it's you know, independently tested or something like that. They assemble that as a block, and then you know, that's probably maybe a some sort of production test sticker or something like that, and then they test that separately and then just bolt it on there. That's the most likely scenario anyway. But they didn't do that with the rest of it here. They just, that's all just in one integrated block. Right, after 20 million bloody screws. There we go, got it. Woohoo! Oh, check it out. Now, of course, none of this is going to make much sense unless we do a basic block diagram here, and that's what I've done. Of basically a very top-level block diagram of how this thing is going to work. Now, over here, we've got our RF input here, and there's our RF input. We're going to have our attenuator section, of course. It's a fully programmable attenuator, of course. That's going to be within inside this RF block here. Actually, on second thought, it could be entirely feasible that this board is just an attenuator board, and that's basically it, just doing the input attenuation stuff, and then all of the bandpass, you know, so basically it could just be effectively, you know, just that on the front end. Maybe some extra filtering or something, but it's entirely possible that all of the, you know, the spectrum, the traditional spectrum analyzer stuff of the local oscillator with the filters and the mixers and everything else, the multi-stages of those, is actually all done on the more complex board. Really, it makes sense because the, you know, the performance of these things, absolutely critical that the input attenuators and, you know, input preamps and stuff work absolutely, you know, perfectly. So that's why these are the only things that are effectively double shielded like this. I mean, they've got their own shielded can inside the already shielded block. Absolute critical performance in terms of noise floor and stuff like that. So yeah, I reckon that's just the input board effectively. And that is likely popping out of one of our RF connectors here or here, which correspond to that connector there, and that one there. So that one pops in just about there. Sorry, this side here pops in on this corner over here. That looks like it could be a bandpass filter in there, off to the ADC, and then we've got all sorts of control stuff, or it could actually be this one over here, because that looks like an extensive bandpass filter as well. We'll take a good close-up look at that. Probably a mixer somewhere in there. I don't know. I'm not going to follow this all the way through and trace it, but it's going to have that basic functional block diagram. There's lots of control stuff and other things on here, which we won't bother with, but of course the ADC, as we saw, is back on the main board. It's not actually on this particular board. There'll be no surprises under there. That'll be another Cool Runner Xilinx control chip, but that's about it for the block diagram. Of course the ADC is then going to go into the DSP, so all that is on the second board. So I don't know, these bloody spectrum analyzers are incredibly complex beasts, let me tell you. I don't know. If you want to figure it out, go for it. So there's our board-to-board RF interconnect there, and that's of course jumping straight through there. You can see the lack of V as it's jumping through series termination resistor there, through to here, up to here, and that looks like it's some sort of bandpass, fixed bandpass filter. Of course, these big fans going off here, they're actually acting as capacitors. We've got little inductors in there, so that is going to form a filter. And then of course the output of there looks like it jumps up into here, into this device, and it comes around here. Some more filtering action happening there, and then we've got some more filtering, another bandpass filter. You might think, how does this work? It's not even connected. Well, of course, two plates like that is a capacitor, so that signal can actually jump all the way over to there, no problem whatsoever. That's RF PCB design for you. Then we've got various then we've got another amp here. Then we have, looks like maybe that's like acting as a controlled impedance transmission line or something perhaps. So they've got a various mix of technologies, and we won't go into details on those. I've explained that a bit in previous videos, but apart from that, that looks like it ends the RF. Oh, Voodoo, no, there we go. We've got another one over here. There we go. We've got another filter happening over here. And once again, instead of the fans, they've got the little pads there. Lots of technology, of course, goes into actually designing these things and ensuring that their performance, you know, is smack on target, because you can get better performance on the PCB than you do using discrete components. It's, you know, a very controlled impedance material they got in here. They'll know the exact dielectric constant and characteristics of it. They can program that into their RF filter layout programs, which then you can simulate and design all these things. But there you go. That is, there's lots of sections on here, and I could try and decode it until the cows come home. Unfortunately, I have to go home. But I don't think the fun's over yet, because if we pop it over, I think we're going to see a bit extra on the bottom here. Oh, hello. In fact, we get a lot extra. Look at that. Oh, beautiful. Wow, that's more than the top. Fantastic. We've got more little hybrid modules down there. I'm not going to look up the number. They're probably like, you know, from Mini Circuits or someone like that, one of the providers of such thing. We've got some complex filtering network happening here. Your guess is as good as mine. If any RF experts out there want to actually tell us the exact configuration and performance of that thing, please do. But that is absolutely brilliant. But as with all of these, you can see the signal flow. I mean, you know, there's obviously signal flowing through just that little gap there on the inner part of the board. Then we're going through our complex network over to here. It's jumping over to here. This is probably jumping over to there. More low pass and band pass filtering happening there. Another one of those hybrid modules jumping over there. Once again, the signal just jumps straight through there on the bottom side of the board, goes up, blah, 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 all over the place. And then these cans look interesting. Let's take a look at those. And that's a ZCOM Crow 3750A-LF. That's a voltage controlled oscillator module. And if we jump up here, what do we got there? Another VCO by the looks of it, but another manufacturer, SMDI. I presume it's a VCO, VCO 190. Oh, look at that. That's a thing of beauty and a joy forever. Beautiful. Somebody had fun there. Oh, let's just, rotate them at the odd angle there. Little bit of inductance just, snaking through on there. Beautiful. And then the capacitors either side. More funny business happening on that one. Check it out. They decided, let's put a little extra loop up there. I wonder what that does. Oh, check it out. You can practically see the waveform coming out of that thing. So that, folks, is all she wrote on the teardown. Unfortunately, I'd love to go into details and do schematic overlays of each block and stuff like that, but that would take all day. It really would, or more. Absolutely phenomenal. So I hope you enjoyed that. A big thumbs up to the Agilent RF division for sending this in for the teardown. They were pretty gutsy. I hope it goes back together. I don't know. We'll see. Anyway, I'll reassemble the thing tomorrow and hopefully it will work. But that's it for the teardown. And if you want to, by all means, go through and what some people have done for the previous ones, go in and actually decode all the different blocks in there. But geez, it's pretty complicated, and you can see that each one has its own individual shielded, section, components both sides. Brilliant. We've got our voltage controlled oscillators, our local oscillators, our bandpass filters, all sorts of RF magic. And don't you just love the filters on the PCB? Absolutely brilliant. I love that. But that's inside a $18,000 high-end Agilent handheld spectrum analyzer. So huge thumbs up to the guys at Agilent for sending that through. And if you want to discuss it, jump on over to the EEVblog forum. That's the place to do it. Catch you next time.